Hey everyone, I've been working on a real-time stock market data pipeline on AWS, and I wanted to quickly share what I have built. So I started by building a Dockerized Python service that continuously fetches livestock data from APIs like Y-Finance, that is Yahoo Finance. This service is running on an EC2 using an IAM role for secure access. So on this architecture diagram, it's outside the AWS cloud, but inside my structure, it's inside the cloud. So it's running on an EC2 server. And this service then streams the API responses into the Kinesis data streams. So Kinesis is acting as a real-time data and analytics pipeline, and the data is then processed in real time using AWS Lambda and stored in DynamoDB for low latency access. On top of that, I have enabled DynamoDB streams, which triggers another Lambda, uh, uh, which triggers another Lambda whenever new stock data is added. So this lambda analyzes the price trends, detects any kind of anomalies or buy-sell opportunities, and sends an email notification to the user using AWS SNS. I also store raw data in S3 to support historical analysis using Glue and Athena. And this raw data can be used to train machine learning models on stock trends. Now, I'll be quickly going over the whole workflow of the project. So this is the EC2 server that is running the Dockerized container that is running the Python script. So I'll go inside the EC2 server and I'll start the Docker container. Now this Docker container would be running the Python script that would be fetching the data from the Y-Finance API and would sending it in real time into the Kinesis pipeline. So this is the Kinesis pipeline, and if you go to the monitoring section and if we refresh it, so maybe we can see it. Mhm. I think it takes some time to actually uh, reflect on this graph. So maybe we can just go to the DynamoDB table and maybe just query the data. We can go to next explore items. So we have table. So I'll click this table. So these are the records that is stored. So as you can see, it is getting stored. So I have this is the process data that is getting stored inside the DynamoDB table. Right now I have 45. If I refresh it, I still have 45. So now, as you can see, it increased. If we look at the timestamp, we can even sort it maybe. So yeah, it's showcasing the time in maybe some other format. I don't know. It's GMT maybe. Yeah, it's 610. So yeah, it's 610. So yeah, this is the latest data that has been appended on the table. So at the same time, we can look at the stock S3 bucket. So this is the S3 bucket that I'm using, and this is the raw data. And AAPL is a stock symbol for Apple stock. Right now, 43 objects, and if I refresh it, I'll have 47 objects. And if we look at the last modified, so it's not the latest one. Oh yeah, this is the latest one. So 1140. So yeah, it's 1140. And this is the latest data. So we can see that the data is actually being stored in real time in both the DynamoDB and in the S3 bucket. As I go back to my architecture diagram, so it went through the Kinesis pipeline, got so data got processed and stored in DynamoDB, and the raw data got stored into the S3 bucket. So let's first go to the process data route. So this DynamoDB table. So I have set up a DynamoDB streams for this stock market table, and this stream is being used as a trigger for this Lambda function, that is the stock trend analysis function. So what this function does is it basically takes in the it checks if there's any update on the table. If the new data is inserted on the table, it basically triggers this lambda function, and this lambda function then uh, acts as an act ups and then checks if there's any kind of anomaly in the stock. or maybe there's a buying or selling opportunity over the here. So if it is, then it will send the request to the SNS service, and that the SNS service would then send the email to the subscribed users. So this Lambda function is basically doing that. So you can see it is taking the DynamoDB table here, and this is the SNS topic ARN that I've created over here. So this is the ARN, and it is being used here, and it fetches the data, and basically this Lambda function start here. So we'll get the symbols. We can have multiple stocks as well. But right now for this demonstration, I'm using the one stock symbol, that is the Apple stock. So we'll iterate over this array, and then it will get the stock data. And if the stock data is less than the 20, it means we don't have enough stock data. So there's no need to check for anomalies for this particular symbol. Then we calculate the SMA, that is the moving averages of recent five stock data, and we do that for 20 stock data. So it is a long time average, and this is the short time average. Then we get the previous short time average and previous long term average, and then we look if not any of them is not none, it means all of them has some kind of value. So we'll try to get a message. So we'll detect if any uh, change has happened. If maybe it is an uptrend, so we can update the message value to this. And maybe if it's the downtrend, and we should be selling the stock, so the message would be updated to this. And if the message is not null, so basically if at the starting we have set up it as null. So if any of the these cases have been run, the message value would have been updated to some kind of value. So definitely this would not be null. So then we'll be going inside this if block, and we will try to uh, publish this message to this simple notification service, and then it would be sent to the all the subscriber of that particular service. So yeah, this is the notification service, and right now there's only one subscriber, that is me, and maybe even I can showcase you if I've gotten any mail or not. Oh yeah, so as you can see, I've gotten various mails, and quite they are quite it's been like 5 minutes ago, 9 minutes ago, and I got one 9 minutes ago. So yeah, it is working in real time. As you can see, this is in downtrend, so I should be considering to sell the stock. So yeah, that was the workflow for this process data and how the notification system would work. And now if we talk about the raw data, so we can just go over that quickly. So this is the raw data, and it is being stored inside this. Not this one. Yeah. So no, not this one. Let me get it. No, yeah, this one. Okay. So this is the JSON data that is getting stored inside the S3 bucket. It's the raw data. So if I update it, refresh it, yeah, so I got new objects. So maybe I can stop this service. And as you can see, this Python script has been running in the background, and it has been sending. So you can see the shard ID of the Kinesis uh, pipeline. So maybe I can just stop this as of now. So yeah, this is the S3. So now we have created a AWS Glue catalog table. So in this database, we have a database as well. So we go inside it. We have table, and I have defined a schema. So this is a schema. So basically, what it does is it gets the uh, raw data from this from S3 and converts it to this kind of structure, so that when we try to query it from the Amazon Athena is a serverless SQL. So it helps to run SQL queries on data, and it works serverless. So when we try to run queries, so it works. So maybe we can try to run some queries as well. So let's run it. So I can do select from this table. The table name is stock data table, and I can run this query. So before running this, I'll just go to the S3 bucket. So this is the bucket where the query I'll be writing would be getting stored into. So just to give you the before and after. So right now I have 8 objects, and the most recent one has been done quite a long time ago. Not quite a long time ago, but a few hours back. So I'll run this query, and I'll be getting the results. So these are all the stock data that I will be having. So if I go to the S3 bucket, I'll be having a new object here. So if I refresh it, I got a new object. And if I so this is the new object that I got. So I got a metadata plus a CSV file. If I go and download it, as you can see, it is the response of the SQL query that I wrote. That was it for the demonstration part. So this project helped me understand how event-driven or real-time systems and serverless systems are designed end-to-end on AWS. I'm looking forward to improving this in future and learning more. Thank you.